Space is vast, an endless expanse that stretches beyond our wildest imaginations. It's filled with billions upon billions of galaxies, each one a cosmic city of stars, planets, and mysteries waiting to be uncovered. And at the heart of most of these galaxies, we find something truly remarkable: a black hole, a region where the laws of physics as we know them cease to apply. These objects are shrouded in mystery, enigmatic and powerful, drawing in everything that comes too close. They are places where the very fabric of space-time is warped beyond recognition, twisted and contorted by immense gravitational forces. Black holes are the ultimate cosmic abysses, regions of space where the pull of gravity is so strong that not even light can escape. Imagine a place where gravity is so strong that nothing, not even light, can escape. This is the defining feature of a black hole, a point of no return. This is the defining feature of a black hole, a boundary known as the event horizon. It's a region of space-time cut off from the rest of the universe, a cosmic prison from which nothing can escape. Once something crosses this point of no return, it's lost forever, swallowed by the black hole's insatiable gravity. The existence of black holes was predicted by Einstein's theory of general relativity, a groundbreaking theory that changed our understanding of the universe. It's a theory that revolutionized our understanding of gravity, showing us that massive objects can warp the fabric of space-time itself. Black holes are a testament to the power of this theory, demonstrating that gravity can warp the universe in truly mind-bending ways. They demonstrate that gravity can warp the universe in truly mind-bending ways, creating regions where time and space are stretched to their limits. For decades, black holes were merely theoretical constructs, mathematical curiosities that seemed too strange to be real. They were mathematical curiosities that seemed too strange to be real, existing only in the minds of physicists and in the pages of scientific journals. But today, we have overwhelming evidence that black holes exist, thanks to advancements in technology and observational techniques. We see their effects on surrounding stars and gas, watching as they influence the motion of objects in their vicinity. We even have images of their shadows, captured by telescopes like the Event Horizon Telescope, providing us with a direct glimpse into these cosmic giants. To understand black holes, we need to understand the life cycle of stars. Stars are the fundamental building blocks of the universe, and their life cycles are both fascinating and complex. Stars are born in giant clouds of gas and dust, known as nebulae. These nebulae are often referred to as stellar nurseries because they are the birthplaces of stars. Gravity pulls this material together, causing the gas and dust to clump and form dense regions. As the cloud collapses, it heats up due to the increasing pressure and density at its core. Eventually, the core becomes so hot and dense that nuclear fusion begins. This marks the birth of a new star. Nuclear fusion is the process that powers stars. It involves the fusion of lighter elements into heavier ones, releasing vast amounts of energy. Specifically, in the core of a young star, hydrogen atoms fuse into helium, releasing tremendous amounts of energy in the form of light and heat. This energy creates outward pressure that balances the inward pull of gravity, maintaining the star's stability. For most of a star's life, these forces remain in equilibrium, allowing the star to shine steadily for millions or even billions of years. But stars don't live forever. Over time, they exhaust their nuclear fuel. As they run out of fuel, their cores can no longer sustain nuclear fusion, leading to significant changes in their structure and behavior. When a star much more massive than our Sun exhausts its fuel, it can no longer support itself against gravity. The core collapses catastrophically, leading to a dramatic end. This collapse triggers a supernova explosion, one of the most violent events in the universe. The explosion releases an enormous amount of energy and can outshine entire galaxies for a short period. The remnants of this explosion depend on the star's original mass. The outer layers are ejected into space, creating beautiful and intricate nebulae. If the core is massive enough, nothing can stop its collapse. It continues to shrink under its own gravity. Gravity overpowers all other forces, leading to the formation of an incredibly dense object. The core collapses into an infinitely small point called a singularity, where the laws of physics as we know them cease to apply. This singularity, surrounded by a region of space-time from which nothing can escape, is a black hole. Black holes are among the most mysterious and fascinating objects in the universe, challenging our understanding of space, time, and gravity. Black holes come in different sizes. The most common are stellar mass black holes. These black holes have masses a few times that of our Sun. They are formed from the deaths of massive stars. Then there are intermediate mass black holes. These are thought to form from the mergers of smaller black holes. They can have masses hundreds or thousands of times that of our Sun. At the centers of most galaxies, including our own Milky Way, lurk the true behemoths, supermassive black holes. These monstrous objects have masses millions or even billions of times that of our Sun. Their origins are still a mystery, but they play a crucial role in the evolution of galaxies. Imagine our Sun squeezed into a space the size of a small city. That's the density of a stellar mass black hole. Now imagine a black hole with the mass of a billion suns, squeezed into a region smaller than our solar system. That's the scale of a supermassive black hole. Falling into a black hole would be the ultimate cosmic adventure, albeit a one-way trip. Imagine the thrill and terror of approaching such a mysterious and powerful entity in the universe. The journey would be filled with awe-inspiring sights and unimaginable forces. As you approached a black hole, you would experience the extreme effects of gravity. The gravitational forces would become increasingly intense, pulling everything towards the center with an unstoppable force. The gravitational pull on your feet would be much stronger than on your head. This difference in gravitational force is due to the immense tidal forces near the black hole. This difference in gravity would stretch you out like spaghetti, a process aptly named spaghettification. But that's not all. The closer you get, the more extreme these forces become, elongating your body in a dramatic and fatal manner. Time itself would behave strangely near a black hole. The intense gravitational field warps the fabric of space-time, causing time to slow down. As you fell closer to the event horizon, time would slow down for you relative to someone watching from afar. This means that while only a few moments might pass for you, years, decades, or even centuries could pass in the outside universe. This effect, known as time dilation, is a consequence of general relativity. Einstein's theory predicts that time slows down in the presence of strong gravitational fields. If you could somehow survive the fall and send a message back out, billions of years might have passed for the outside universe. The universe you once knew would have changed beyond recognition. Black holes also act as gravitational lenses. Their immense gravity bends the path of light passing by, creating fascinating visual effects. Their immense gravity bends the path of light passing by. This bending of light can create multiple images of the same object, or even ring-like structures known as Einstein rings. This bending can magnify and distort the images of distant objects behind the black hole. The light from these objects is bent and focused, making them appear larger and more distorted. It's like looking through a cosmic magnifying glass. This phenomenon allows astronomers to study distant galaxies and other celestial objects that would otherwise be too faint to see.